So up into this video, we are now at a stage where we know somewhere in between 2 and 3, there's a number somewhere in between 2 and 3 where the derivative of this line is itself that line, and we don't know what this number precisely what this number is. We're just going to call it e for the time being. So we know there's a number in between, a constant in between there. When you differentiate it, it will be itself. Okay, so we don't know the precise number of this e here, but we know that it exists somewhere between 2 and 3, so that when you differentiate it, it will be itself. So now what happens if we want to differentiate something like a constant in front of e to the power of x? So how would you go about differentiating this? So as normal, our normal routine. So now let's try and work out the derivative of this. How would you go about differentiating this when there's a constant in front of e to the power of x? So our normal routine is to look at this x here, add a tiny amount onto there, so that's this bit here, and then take away the original, and then divide it by h, and then take the limit as h tends to 0. Now from here, you can see that 2 is in common here, 2 is in common here. You can factor out the 2 here. So now it's 2, because if you get this times this times this, it will give you this thing here. My point here is that 2 is in common, you can factor out the 2. Okay, and from one of the properties of limits, because we are taking the limit as h tends to 0. Remember, h is moving about. We are decreasing h each time. So this 2 here is a constant. So we can actually take it out here. So we are using one of the properties of limits. So that would be this thing times this thing here. So now don't forget, this thing here is well, if I were to say to you, how would you go about differentiating e to the power of x? You would how would you go about differentiating e to the power of x? You would say, oh, I'm going to add a tiny bit amount at the end here, so that would be e to the power of x plus h. Take away the original, which is e x, and then divide it by h, and then take the limit as h tends to 0. So you see, now when we are here, that's this bit here. So now we can go backwards here and say that this is dy. Well, we are just working backwards here. So this thing here is really, this box here is really the differential of this thing here. Well, when you differentiate this thing here, it's just e to the power of x. So when you are at this stage here, you can actually say it equals 2 and then times well, this thing here is e to the power of x, because this thing here, don't forget, this thing here, this box here is really d by dx of e to the power of x. So then how would you go about differentiating this? It would be itself. So this thing here becomes 2 times e to the power of x, which is 2 e to the power of x. So when you differentiate this here, even though there's a constant in front, then it really becomes 2e to the power of x. Even though there's a constant in front of there, it will still be this. Okay, so in general, if you differentiate this, it will give you this. Okay, and if let's say you want to differentiate, this here, even though there's a 7 in front of here, in front of the e to the power of x, it will become this. Okay, yeah, so bear that in mind.